Everybody, we'll discuss regarding the product life cycle. Typically is shown in the basic process of machine design. It starts from recognition of the need. Generally, the need of the machine design or a component or the element, it should be raised by the customer. But always it may not be raised by the customer. Some of the needs are to be raised as a part of the business. Now the customer knows, or customer come to knows, that is what is his need. For example, in old days we are using the bullock cart. Now suppose I want to go from college to the city, I require half an hour. My need is that I should be able to reach from the college to the city within 5 minutes. Now by bullock cart it is not possible. Additionally, I add few more things, that I should require more comfort. I require the fuel economy is also required. Now this is being added. Now this is my need. Now once the need is being recognized, that has to be formulated properly. That is, we have to define a problem. What is my problem? I have to reach from college to the city within 5 minutes, whatever may be the distance. Then I require a comfort. I should get the fuel efficiency. It should be a cost effective. I should get a proper vehicle that will give the good comfort to me. This is my problem. Now that problem has to be synthesized. It has to be divided into the smaller and smaller part. Every part has to be studied in the proper way, so that whatever the problem is being defined, that problem is going to satisfy the need of the customer. Then once the problem is being synthesized, we have to go for analysis and optimization. Analysis means what are the problem we have defined. In the synthesis, small and small parts are being created. Every part is to be designed properly. It should be within the limits. It should not exceed the limit. It should not get fail. And what are the components are being designed, it should be in optimum condition. If it is not in optimum condition, even though the model which is being designed or the part which is being designed is of no use. For example, suppose I had designed a vehicle which will reach within the 3 minutes from college to city, but his fuel efficiency is not good. That is, it will require 2 kilometer per liter. Then it is not optimum, it is not affordable to a customer. Therefore such a model is not able to sustain in the market. Therefore whatever the components are being designed, it should be optimum one. Otherwise, even though it is a good product, it is not sustainable in the market. Then third one, next step is, that is, we have to go for evaluation process. Once we will go for evaluation means what are the components are being designed, whether it is sustainable in the market, or whether it is suitable in the market, whether it is going to satisfy the needs of the customer, whether whatever is being defined, it is being covered in the whatever the product is being developed. All these things are being verified in the evaluation process. Once the model is being evaluated, that should be presented in front of the audience. It should be the open audience, so that it will give the feedback, and whatever the feedback is being given by the audience, that will be incorporated in the recognition of the need. Many times the companies are getting a survey, what is the mindset of the customer. Now we are in old days, we are not much more aware about the pollution content of the vehicle. Whatever the emissions are being created, we are not worrying about the pollution. But nowadays people are also worried about the pollution, because that pollution will create a polluting the environment, and which is hazardous to our health. Therefore people are also asking, that is, low emission vehicles. That's why we are going to switch to the lower emission vehicle. Now this need is being generated through the discussions or the survey through the audience in the presentation. In such a way, the needs will be generated. This is the simplest way of basic procedure for the machine design. Now this is another chart. Similarly, it shows few added element of team selection and startup. The first thing is the business need identified. Now, every time the need will be given by the customer, this may not be the case. Sometimes the needs are being generated by the businessman. Okay, now whatever it may be, the need is the basic step. Then once the need is being defined, then problem definition or project definition has to be defined. Then a team selection. Now, a problem cannot be solved by a single person. It requires certain team. Now, if team is suitable, if members are suitable, if members are sufficient, then that problem can be solved easily. Therefore, the team selection is one of the important aspect of the project definition. Then the startup should be there. Then we have to plan in the synthesis. Everything has to be defined into the mind part, that is the plan. Then we have to go for organization, then implementation and control. This is the entirely project work, repeated feedback cycle. Then we have to deliver the plan, and we should go for a commercialization of the project. This is one more product life cycle is there, which will define from inquiring, developing, creation of the solution and evaluation. Okay, it will satisfy. Now, if a short note is being asked, you can draw any one of the diagram and give the detailed explanation for that. Now we'll go for some of the design steps. What are the design steps are there? Design is being classified into the 4 to 5 major steps are there. First of all, we have to design and define the function. What is the usefulness of the product? Then we have to go for a determination or the calculation of the stresses, what forces will come, what are the strengths will come. Everything has to be validated. Then next one is we have to go for material selection. This is the most important step. In material selection, it should be cost and availability, manufacturing and material mechanical properties. If we have selected a material which is very good but it is not cost effective, then such materials are not helpful. The next one is there are failure. What are different failure modes are there? That is elastic deformation, yielding, fracture, breakage, whatever it may be there, whatever may be the modes of failure will be there, that all should be decided. Then determination of dimensions of the critical section, design modification and design for manufacturing, preparation of engineering drawings, that so that this is the routine process of a design. Now let us see this design steps in the flow chart. Now first step, it indicate that is the need or the aim of the design. Then we have to go for a synthesis of the design. That means every aspect has to be validated or checked. Then analysis of the forces, that is the calculation step is there. Then material selection and design of elements. Okay, now once the design of elements, it will do the calculation. If it is not satisfied, then again go for a changing of material, change the material or change the factor of safety, again do the calculation. This is the closed loop cycle. Once it is being satisfied, then go for a modification in design and optimization. Once it is being optimized, then go for a detailed drawing, and last one is go for a production. Now the next step of our design is nothing but design considerations. There are different design considerations are there, like a strength, rigidity, wear resistance, friction resistance, minimum dimensions of weight, manufacturability, safety, then minimum cost, life cycle cost, and some reliability, maintainability. Some other design considerations are there. Let us see one by one. First one, strength. Now strength, this is the material property. What is the strength? It is the ability of the material to resist without rupture with the external forces causing the various types of stresses. What does it mean? That is strength. The parameter is linked with the modulus of elasticity. There are two strengths are the yield strength and ultimate strength. For ductile material we are going to consider yield strength, and for brittle material we are going to consider the ultimate strength. Because for brittle material the demarcation line between yield strength and ultimate strength is not available. For ductile material demarcation line between yield strength and ultimate strength is available. Now for ductile material, whatever the stresses are going to develop, that should be below the yield limit, provided that the forces are static. If forces are fluctuating load, then the component will fail below the yield limit, and that limit is called as the endurance limit. Okay, the parameter link with this, it is the modulus of elasticity. Then next parameter is that it is the rigidity. It is the ability of the material to resist a deformation under the action of external load. The parameter related to this is modulus of rigidity, G. Now, whenever the component is subjected to the forces, it get deflected. This deflection will create a stresses, and that will lead to the failure. Then last one is the toughness. It is the ability to store the energy. Now this is useful in the design of a spring. There are some mechanical properties are there that we already studied. Is modulus of elasticity, then modulus of rigidity, ultimate strain, ductility, thermal expansions. Okay. Okay, thank you. That we have discussed all this thing. We'll discuss the remaining thing in the next class. Thank you.